And we're on.
There we go.
Do we all have the quiz pulled up?
I got mine.
Yeah. Yep.
Sweet. So we can just begin. Okay, I can read number 3.
Okay.
When you are taking a sample size of n equals 5, what is the shape of the distribution of means histogram when the parent population is right skewed? I think it just skewed right.
Yeah.
I think.
Normal? Might be normal. No. It's not normal. It's not drawn from a normal population. So I think it'd just be skewed right.
Yeah. This is kind of a short chapter.
I know, but I feel like after reading that first question, I feel like it wasn't very descriptive. Now I'm like,
Yeah, that's how I feel. Like
That's how I feel usually, though. So, yeah, should probably study it a little more thoroughly, I guess.
that or like the homework assignment thing.
True.
I always like the answers are right there, so I usually don't pay too much attention to it. But okay, we can say skewed right because that makes sense to me.
Now it asks, when you are taking a sample size of n equals 100, what is the shape of the distribution of means histogram when the parent population is right skewed?
Okay, this one I'm thinking is normal because I remember, like in the central limit theorem, it's if the sample size is sufficiently large, then it's normal, and large is anything n greater than 30.
Oh, yeah.
Okay,
I'm pretty sure that's normal.
cool.
Okay.
When you are taking a sample size of n equals 5, what is the shape of the distribution of means histogram when the parent population is normally distributed?
Normal, I believe. Because if data drawn from a normal population, it is normal. Is
Yeah.
also central limit theorem.
Okay, cool.
Perfect.
So really, the only thing I'm pretty sure I'm 3. Okay. 6. When you are taking a sample size of n equals 100, what is the shape of the distribution of mean histogram when the parent population is normally distributed?
Isn't it normal? Did we just go over this?
Yeah.
Okay, just making sure.
I sure hope I am not just leading you guys astray.
2 attempts. I'm not worried.
Okay.
Yep.
Good point. Okay.
I can read this new one. When would the distribution of means be normally distributed? Choose all correct responses.
So there's 2 of them. And I just wrote them down.
Okay.
Data drawn from a normal population, is that one? Data drawn from populations normally distributed in the sample sizes small.
Check that expiration date.
Sample size sufficiently large is another one.
Wait, so which ones are these?
I think that would be the top 2.
Top 2, okay.
Yeah. Man,
Okay. 8. Which of the following gives the best explanation of the central limit theorem? If the parent population is normally distributed, then the sample mean will follow a normal distribution. For bell-shaped data, approximately 68% of the data will be within 1 standard, 95% of the data will be within 2 standard deviations of the mean, and approximately 99.7% of the data will be within 3. If the sample size is large, the sample mean will be close to the population mean. If the sample size is large, the shape of the distribution of sample means will be approximately normal.
I think it's the first one.
Yeah.
Because it is almost verbatim of what the chapter says. I was checking it at the same time.
Cool.
I was waiting between that one or the last.
I think it's the first one too. But I don't know. You're welcome to put.
Okay, it's my turn. I think so.
Yeah.
Okay, let x be a random variable with population mean. I don't know what these signs mean, just first off.
So the U is mean and the O is standard deviation.
I should like write these down. Okay, so let x be a random variable with a population mean equals 10 and population standard deviation equals 6. Suppose the sample size 36 is drawn from the population. So what is the mean of the distribution of sample means?
Let me.
Okay.
The mean of the distribution. I have no clue.
I know. Where's something? Oh.
I think it might be 1, but I don't know. The only equation I've seen is the O divided by the square root of n. And so the square root of n would be 6. 6 divided by 6 is 1.
Mm-hmm.
But that's, I mean, other than that, I don't really see any equations.
Yeah, where did you get that equation?
That's like. Sorry, go ahead.
No, you're okay. It's in like the law of large numbers and the mean and standard deviation for the distribution of sample of means.
Oh, I see right there. The standard deviation of the sample means is the standard deviation divided by the number or square root of the number, right?
Yeah. So I'm guessing it's 1, but I don't know.
Oh yeah, because 6 divided by 6 is 1. Let's do it.
That could be wrong, but.
What's the standard deviation of the distribution of sample means?
Oh wait, maybe that one's 1.
Yeah, that's the next question.
What is the mean of the distribution of sample of mean? Oh
That's
wait, this is
question 9, yeah. And then question 10 is what is the standard deviation of the distribution?
Oh wait, I think the mean is always the same.
Yeah.
Mean will be 10, and then I think the next answer is 1.
Sorry, I'm writing it down. Yeah, that's correct.
Okay, regardless of the distribution of the population, if the sample size is large, what would be the shape of the distribution? That's right skewed, right? Maybe. Or normal, I mean.
The sample size, okay, so regardless of if the sample size is large, normal.
Yeah.
What's bimodal? I don't remember that word. Okay. Oh, 12.
Oh, sorry. Go ahead. Oh, sorry.
What theorem would you justify your response to the last question? And that is central.
Isn't the law of large? No.
So the law of the large numbers, I have that one written down. That's as the sample size gets larger, the sample mean will get closer to the population.
Oh, okay. Must have just confused them.
Yeah. But I don't think we ever did anything with the law of large numbers.
Oh.
The only thing we did with the law of large numbers, I think, is like to help find the standard deviation of the distribution.
Oh, yeah.
Okay.
Okay, I'll keep mine open again so we can.
Okay.
Cool. I'm submitting.
Me too.
Okay, did you get 8 wrong?
Scrolling.
And 7 almost wrong?
Yeah. I mean, I got most of 7 right, but.
Yeah, me too.
And
You just like must have missed one more or something.
I got 8 wrong. Sorry, that's my fault, I guess. Dang.
No, you're fine.
9, 10. Oh, I got 11 wrong.
11 is normal.
Oh, dang it. I put right skewed. I must not have heard us change it.
Sorry, I said right skewed and then I was like, oh, I mean normal. I must have cut out.
Okay.
All right, let's.
So for 7.
Mm-hmm. The 7, we put the first 2, right? But that's not correct. Okay. Did it say which ones are right?
No.
Oh, okay.
Mm-mm. I wish it told us how many answers were correct. Like,
I know.
yeah.
Okay.
The distribution of means be normally distributed. I'm looking back at the chapter.
Yeah, I'm looking at it.
Okay.
What did you put for 5?
For 5?
I can look.
Yeah.
We put normal.
No, that's right. Okay. I'm just like going through and redoing it. So.
Did you need 6?
Yeah.
Okay. 6 is normal. 7. Oh, that's what we're on. Okay.
Yeah. Okay. Caught up.
Oh, that was smart, Mikkel. Now I'm doing it. You may need to repeat those. Just a second. We'll see.
Okay.
One was right skewed, right?
The 3, you mean?
Yeah.
Oh,
Yeah,
sorry, yeah.
Yeah, 3 skewed, right?
And then 4 is normal.
Yeah.
No. 4 is right
Yeah.
skewed. Normal?
4 is
Yeah,
normal.
Oh, yeah, because it's large. Right.
Then 5
5
is
is
normal.
normal. 6 is normal.
Mm-hmm.
And then
And
1
now we're on 7. Okay. I could read the distribution part if you guys want to like look at the answers at the same time.
Yeah.
Okay.
Okay. If a parent population is normal, then the sampling distribution of X will always be normally distributed no matter how many observations are selected. If the parent population is not normal, then the sampling distribution X will approximately be normally distributed if the sample size is large enough.
Mm-hmm.
If the parent population is almost normal, then a sample size of n equals 5 will probably be sufficient to assure that X will be approximately normally distributed. If the parent population is heavily skewed, then it will require a larger sample size to be assured that X will be normally distributed. For most moderately skewed distributions, a sample size of around 30 is traditionally thought to be sufficiently large to assure that X will be approximately normally distributed. This is not a definite number, but it is a rule of thumb.
I
For
think-
tremendously, wait, what?
I think I know the answer.
Okay,
I think it's the first two and the last one.
my backpack, I think. Okay, I was thinking that too.
Okay.
Yeah, because they have the population normally, like for the first two, and the second one, the sample size is large, and then the last one, the sample size is large.
Okay.
Okay.
And then for 8, did you want to try the one you thought was right, Melissa?
Yeah, I just thought the last one.
Oh, now that I read that again, I think that's probably true. Hey, Joey.
Okay. And then the mean is 10.
Mm-hmm.
Yeah,
11 is 1.
you can just take my whole wallet. I don't need it.
What'd you put for 11 is normal. And then the central limit theorem.
Yeah. I'll submit mine.
Wait. 9 is 10. 10 is 1.
Okay, I got
Sorry,
it.
Joey needed my wallet.
Different.
What's 11 again?
Normal.
Normal.
Is
And
it-
12
Central,
is central.
Okay, cool.
and we got 100.
Yay.
Woot.
I always hit the last like save button instead of like submit quiz, and I like wait forever.
Yeah.
Okay, cool.
Well, we did that pretty quick.
Yeah, we did.
A small chapter though.
Yeah.
Yeah, that's true.
We're good. We'll plan on Thursday.
Yep.
Yeah, I'll go on Thursday.
6:30, right?
Yeah, 6:30.
Cool. Sounds good.
Kylie. I now understand it.
What?
Said I understand your shirt and I like it.
Oh, I like it too. I got it on my mission.
I assumed so.
Yeah, my trainer has the same one actually.
Oh, cute.
Yeah. Okay. Well, I think I have to go to Home Depot now.
Yeah, I'll see you all on
Yeah.
Thursday.
See you on Thursday.